The broadcast is now starting. All attendees are in listen-only mode.
Hi, good morning, everybody, and welcome to today's webinar on creating plant projects from as-built to an intelligent model. Now, when I talk about this particular webinar, we will be talking about how do we take up scanned projects and convert it into intelligent BIM model or BIM projects which are therein. My name is Preeti, and I'm an AEC technical specialist, and I'll run you through the whole of these workflow today. In today's webinar, you have a session to post your questions after the webinar in the chat window, and we'll be answering it shortly after the webinar. We even have something like poll questions which needs to be answered. Be sure to answer it on time in order to get attractive goodies or the same basically. Now, before I start talking about scan to BIM or conversion of as-built to intelligent BIM projects, I'll talk about something on what is scan to BIM all about basically. Now, scan to BIM is a process in which a laser scanner or a 3D scanner captures the information on the construction site. Preferably, it could be any EPC projects, heritage projects in that case. And what we're doing is like use those scanned information to convert those details into an intelligent project or a model which is there. Now, why these aspects, or why is laser scanning necessary, or the cloud point information necessary in this case basically? First of all, there are different reasons why we do this basically. Now, there are a lot of, let's take an example of plant projects. Now, plant projects are those projects which are pretty much older, which might be existing for a longer amount of time which is there, and you do not have any digital archive of those kind of information which is therein, and whatever information which you might have might be in the form of paper drawings, and you do not have a proper reference to it. Or the other reasons for having these kind of BIM informed model is being in order to do something related to asset management, or doing the repair and maintenance of that particular plant project. It could be something related to refurbishment of that particular plant project, etc. So there are pretty number of reasons why we do scan to BIM approach, or why do we use those kind of approaches which are there. The second important reason why we convert information from scanned data is because we have lesser amount of reworks involved, because the plant is already ready, and the iterative design processes is not involved in case if you're only converting it into digital information which is therein basically. And it involves into lesser kind of rework, and preferably that particular model could be that particular scanned information can be converted to a BIM model in a very shorter amount of time which is therein. The third important aspect is like the facility management aspect, preferably a quality inspector who is managing that particular plant site which is therein. He needs to have the complete information of the asset, whether it is a pump to a pipe which is being laid on that particular plant site which is therein. Now, these kind of scanned approaches are not only meant for plant or a EPC project. It is even being followed in different kind of situations. For example, in kind of heritage projects where you want to digitize that particular heritage project which is therein, or even in capturing the actual type of work which is happening on the construction site currently. So capturing the as-built information. Today's example which I will be talking about is more plant centric. And let me take you through how these workflow happens, especially for EPC kind of projects which are there in basically. Now what happens is like there are a lot of scanners available in the market coming in from Faro, Topcon, Leica, etc. These equipments which are therein, and depending upon the range and the extent of these scanners, they are laid on the construction site or the layout where the scanned images which needs to be extracted, which is therein, or a cloud point data needs to be extracted, which is therein. So what you're doing is like you typically take that particular layout, you know, station your equipment in those particular locations which are therein, and based on the range of your scanned equipments which are therein, what it could do is like it could take up the panoramic photographs and the full dome scans of all the complete layout depending upon the size of that particular project. And at every station it clicks up a lot of these panoramic and dome based photographs which are there in basically. Now what happens is like what you could do in this case basically. Now based on the type of equipment which you're using, preferably Faro has got its own add-on which could convert these information. Even Leica for that matter, Topcon have got their own set of tools which could convert these kind of information which is there. But particularly in the Autodesk set of solution, we've got a tool called as Autodesk ReCap Pro, and which could take these cloud point information, take these scanned images, stitch those images, and process those information which is therein. So it could take in the output data from any of these file formats like RCS or RCP, which is therein. Yeah, for example, Faro, Leica, Topcon, etc. have their own formats as well in that case. So that could be utilized in processing your information basically. Now, once the photographs or the images are stitched together, it moves on to the next stage of something called as extraction of these data, which is there. Definitely from a scanned data, you do not get a 3D model automatically, basically. Now, there could be different ways and means of doing that. For enabling these kind of aspects, Autodesk has got something very specific in our tool set, which is therein for linking the data which is there basically. So for example, let's assume if it's a kind of a heritage project which needs to be rebuilt, I would use tools like Revit to modify the content of that particular photograph to convert it into an intelligent model. Now, if it is something very specific to plant projects, I might use AutoCAD Plant 3D, which is there basically to convert those into intelligent information. So what I will do in these kind of tools is like, I will preferably model these information. So I'll extract the information from the scan data, start overlaying or modeling on the top of those scanned images which are there in basically. Now these scanned images could be either taken into Plant 3D, either taken into Revit. Now, if it is something related to infrastructure projects, you could also take it into tools like Civil 3D, etc. basically. So depending upon the type of the project, the 3D modeling tool will enable you to model or extract or create an intelligent BIM model, which is there. And the beauty of all these information is once it's been extracted and a 3D model is being generated, what you could do is like these BIM tools which are there, whether it is Civil 3D, Plant 3D, Revit, etc., it could consume those edited information or created information on the top of those scanned images, and you could build up a model which could help you into generating if it is something related to Plant 3D, you could do something like your orthographic drawings, isometric drawings, keeping a report handy for the maintenance aspects, or even taking into the next stage of asset management into tools like BIM 360, etc. If it is Revit, then preferably it could be a heritage specific drawings. You'd require something like a layout including plans, elevations, and sections of that particular heritage model which is there in basically. Or it could be also used for functionalities like refurbishment of that that particular project which is there. And so in case if it is a heritage structure, it might be quite integrate in these details, and maintaining and repairing those intricate information becomes very difficult. So you could use even the impact of 3D printing in order to further repair those heritage assets, etc., which is there in basically. The next part is like what happens in the construction site. Now, while you're doing this refurbishment activity, which is there, in case of a plant project, it could be like the whole plant is getting scrubbed out and a new plant is coming in the place of that same layout where the old plant was existing. Or it could be the maintenance aspect of the plant, like a new pipe which has been completely damaged or rusted. A new pipe is getting installed in that case, basically a revamping of that particular plant, or a shutdown which has been scheduled, maintenances, etc. So there are different reasons why the as-built modeling workflow works in plants, basically. Now, people who are hearing Autodesk Plant 3D for the very first time, Autodesk Plant 3D is a part of the AEC collection tool, which is therein. Apart from bringing the scanned images from ReCap to Plant 3D, Plant 3D has got its own capabilities of creating and modeling, creating PNIDs which are therein, basically, and modifying those PNID diagrams which are therein, basically. The other part it could also handle in is like it could also create, help in create the structures which are around, your plant structures which are therein, basically, especially the piping aspects, routing of your pipes, etc. 3D modeling of your equipments, your structures, etc., which forms a part of a plant layout which is therein. Now, while you're modeling all these information, what you could also do in is like you could also design and document these information in the form of respective reports, orthographic drawings, isometrics, which are therein, basically. And the other piece is like it could be any kind of project, starting from a small a skid project to a larger power plant where you need to do things like piping modeling, etc. Now, the beauty of Plant 3D is like it supports integrated multidiscipline design. What do you mean by that? Is like, for example, the whole plant comprises of steel structures, concrete structures. So in case if you're doing more detailing of concrete structures, preferably you could use extended tools from our AEC solution in order to do detailing of those concrete elements which are therein. And in case if it is something to do with steel detailing, we'll talk about something like using advanced steel for the detailing of those steel structures which are therein. And at the last stage, preferably if you want to do the visualization, collaboration, then definitely we have our tools like Navisworks and BIM 360, which comes handy in this case, where it could allow you to do class checks, coordinations, and collaborations, basically. So that's about Plant 3D. The next tool which I'll be talking about in my presentation is Revit, and I believe majority of the audiences understand what Revit is all about, basically. So Revit is basically a BIM tool which could be used for architectural, structural, and the MEP modeling. Revit can also help in the scan to BIM process which is therein, or converting the as-built information to an intelligent information. Revit also has multidiscipline integration. So you could integrate with the, plant guys, you could integrate with the structural detailing people, which is therein, or any other facets which forms an important part of your project, which is therein. Revit also has capabilities to integrate with a lot of third-party tools for energy analysis, even though it could also integrate with tools like Insight, which forms a part of the AEC portfolio which is therein, or even integrating it with tools like Navisworks, which are therein, where you could do something like interference detection as well, basically. Now, these information which either comes from Plant 3D, Revit, it could be extended for different purposes like, your fabrication aspects, installation on the site, etc., and extracting various kind of outputs from these models which are there. So it's basically Plant 3D, Revit, all Civil 3D are all digital prototypes, which allows you to convert intelligent information basically. Now, today I'll be specifically highlighting and stressing upon our tool called as Autodesk ReCap Pro, which is there. As the name suggests, ReCap, preferably, ReCap is nothing but reality capture. Just to make you understand, ReCap is not a scanning tool which is therein. What ReCap can do is like, it could bring in the scanned information from the laser scanning tools which are available in the market, whether it is Faro, Leica, or Topcon for that matter, and you could bring those scanned images into ReCap Pro for that matter. You could edit those ReCap data in ReCap Pro. When I talk about editing, I'm talking about clearing the speckles, cropping out information which you do not need basically. And it also allows you to stitch those information. When I say stitch, preferably your scanned data which comes from these Topcons or Leica, etc. It is in a form of number of scanned images. So you have the facility of stitching those scanned images. Certain equipments can also directly support the RCP file format, which could be imported into ReCap Pro basically. And what you could do is like these scanned images which are in an RCP file format, you could visualize your 3D data inside ReCap Pro basically. So that's the advantage of the scan visualization. Now, why do you use? Because I'm typically today talking about a plant example, and why is it necessary that you use ReCap with Plant 3D basically? So you cannot only use Plant 3D, better to use it with the ReCap basically. Now, what happens is like, for example, there is already an existing plant and you're trying to create a new plant near that particular old plant which is therein. So what you'll do is like, you could bring the scanned information of that old plant, and ReCap actually simplifies your process. And along with Plant 3D, Plant 3D has got the facilities of equipment, modeling and piping, adding piping, etc. So that becomes very easy to add your equipments and piping to your existing model, where your scan data also forms an important part basically. Now, sometimes, using as-built data becomes very difficult certain times, reasons being as it's not being to proper scales, etc. You cannot get accurate field measurements which are precise, and sometimes it could be even time consuming, which is therein. So there is where the combination of ReCap and Plant 3D eases that particular process which is therein basically. And the other piece is like these laser scans can ease the task of modeling new equipments and new piping, because you've already gotten reference, and it could become very fun modeling on the top of these as-built data which is therein basically. There could be more reasons to it. So these are some funny snapshots why as to ReCap should be used with Plant 3D. Something like a piping guy brings a pipe out of his window, which shouldn't be an ideal case basically, or something like a rusting of the structural elements which are therein, and preferably you want to maintain this particular plant or refurbish this particular plant which is therein basically. So these are the other reasons also why you could use ReCap with Plant 3D. Now, how does this whole process work on the site when you're doing as-built scans basically? Now, what I've done is like, as a part of a live example, we have taken a basement facility. What we did is like, we have scanned this information. The image which you currently see is scanned by equipment from Topcon, which is like GS 2000. And what they did is like, as the plant size was too large, these stations or these equipments that moved to different location, and the whole plant, it took almost 80 minutes to scan the whole plant which is therein. And the time, if you see, it took 80 minutes, but preferably converting these scanned images and stitching those point cloud data, etc., it took almost 15 minutes to generate this information in recap basically. So depending upon the number of scans and the amount of data precise, you could do these field to office switching, stitching very easily by using the point cloud data workflow which is there basically. Let's talk about the process. So let's understand how this process works currently between ReCap and AutoCAD Plant 3D for that matter, basically. So I'll talk about how to import these registered scans and how the process moves on, basically. First of all, in case if you've got any scan to BIM projects, or you're converting as built to BIM projects which are therein, and if you're using AEC collection for that matter, please install the tool which is Autodesk ReCap Pro, which is therein. Now, once you install ReCap Pro, ReCap Pro has got different options for creating up a project. So on the right hand side, you see an image of how do you create a new project. So click on the process of creating a new project and look out for this particular icon when you're trying to create up a new project. Once you say that you're setting up a new project, define where your point cloud data is lying in, or preferably the folder where your point cloud information is being lying in basically. So it could be lying in somewhere in your the plant project folder location as well, and you say that you want to import this point cloud information which is there basically. Now Plant 3D or ReCap along with Plant 3D can integrate or take up a lot of formats which are there in basically. So it could be coming something from Leica, it could be coming in from Topcon, which is therein, it could be coming from Faro, etc., or it could be some open file formats, or it could be even the ReCap file format like RCS or RCP for that matter, which is there. So first, you select the process of importing those scans, because you need to register those scans into ReCap first before bringing into Plant 3D. So you go through the whole process of importing and registering the scans. The native file formats of Autodesk ReCap are RCS, which is therein. So the ReCap scans could be bought in the format of RCS in this case, basically. And majority of these equipments can also generate, like Hope you're able to hear me right now. And in case if it's yes, just type a message in the chat window, please.
Yes, we can hear you now, Preeti.
Avinash, hope you're able to hear my voice. Yeah.
Yes, Preeti,
Okay.
we can hear you now.
So once you want to bring these scanned images into Plant 3D, what you could do is like you have got these functionality in the top of Plant 3D where you could use the Autodesk ReCap command and you could insert or attach these registered scans into Plant 3D basically. And what you could do is like while you're trying to attach these information, preferably it opens up recap. It indexes those scans and preferably it also opens up recaps and attach those file formats basically. Now the next piece of information is while you are registering these scans which are there in basically, you could also add piping and equipment information. And when you're trying to create this AutoCAD Plant 3D model, which is there in basically, it creates a RCP file format. Usually the cloud project is stored or saved by an RCP file format, which is there in basically. So RCP is basically the file extension of a recap project. Now, while you have started integrating these information inside AutoCAD Plant 3D, what you could do is like while you're attaching these point clouds, be careful about the point cloud coordinates which you're trying to use in, the angles which you're trying to attach, and also taking in care of the insertion points or the coordinates of these scans, which are predominantly important when you are trying to link the scanned information, existing scanned information to the newly created digital model which is there. And scale is one more factor which is important while you're trying to add this information into the as-built model which is there basically. Yeah, so once you have done this aspect, we'll move on to the next aspect. Now, once you have selected your insertions and coordinates which are therein, the point cloud information gets added to your existing plan. So that's the reason I said you need to select the coordinates as well as the scale of this model which you're trying to insert into your existing Plant 3D model so that it exactly sits with the new model which you have created. Now for larger plant models or larger scan areas which are there, we suggest you to create different regions. We suggest you to create different areas into Plant 3D in order to preferably create the existing plant model which is there basically. So this is an example of have a Plant 3D data. Now this particular image which you seen over here, it's a basement facility, and what we have done is like we have taken the information in two different tools. That is, we have taken it into Revit as well as AutoCAD Plant 3D, which is therein. And we followed the same process as I talked about earlier, which is therein. So whatever concrete elements which you see have been modeled in tools like Revit, which is there, and whatever plant elements which you've seen, if it is related to the MEP facility, it is better to do it in Revit. And if it is related to a bigger plant project which is therein, like it could be even modeled in Plant 3D in this case, basically. And the structural elements could be modeled in tools like Advanced Steel for that matter, where you could detail out those elements as well in basically. I'll take you to the next slide where I'll talk about, so that's a visualization of the whole plant facility where I've used a combination of Revit and Plant 3D in order to create this particular piece of project which is there in basically. Okay, few more snapshots. So how did I go through whole of this process which is therein? As I mentioned, I've talked about two tools which are there. I talked about things which is like, taking up the scanned images coming from, your laser scanning equipments like TopCon, Faro, etc. Bringing into tools like ReCap Pro, modifying those information, cleaning up those information in ReCap Pro, stitching those images, etc., which you do inside ReCap Pro, and depending upon the type of the project. For example, as I said, if it is an MEP project, please take it to Revit. If it is related to a plant project, we will take it to Plant 3D. And in case if you want to do further collaboration, etc., class checks on the elements which you have modeled inside Plant 3D or Revit, you could use tools like Navisworks to do these collaboration on the top of your scanned projects, and it could be further linked to your aspects of 4D and 5D as well in this particular case, which is there basically. Now, while I was talking about all these things, what are the effects which happens basically? First of all, you could achieve the concept of something like reverse engineering, where you convert your scan to intelligent model for an existing project as well. In you could create a digital information, which is your single source of truth, which is therein. These information could be used for the plant for the next 30, 40 years for that plant to be maintained basically. This could be used for the asset management purposes as well, or in the future purposes of reworks and refurbishment, which needs to be maintained for that particular plant which is there. And this process which you usually take in, preferably if you go with a normal plant project, you will start off with the process of PNID information which is therein, converting those PNID information to plant models, then generating the documentations which are therein basically. But these scanned approaches helps you in easily creating 3D model, and it also helps in getting better quality information which is there. So that's the reason you should use this approach for scan to bin projects which are therein basically. So that's a 3D cloud rendered image where I've used AutoCAD, Autodesk 3D rendering, where it has got done rendering on the cloud. I could create a 3D, panoramic image of that whole basement facility and see how that basement facility looks like basically. So that's one output which could be generated for as-built information basically. Now, why is it necessary to capture the existing or the as-built conditions which is there in basically? First of all, it's better to scan that environment. And in case if you're building up a new plant, it is better to understand the as-built condition of that particular plant which you're trying to build in basically. Second thing is like the process of moving from 2D to BIM. So moving from 2D to BIM necessarily doesn't mean that you use just plain CAD drawings and then move to BIM. You could also use these approaches when you want to move from a scanned information to a BIM-based information, and all these informations are actually accurate in this case basically. The third point is like, for example, let's assume that you have not you've manually visited that site and preferably captured information about that plant site. Now sometimes it might lead to very, very costly reworks, and preferably in EPC projects the reworks might become too costly in that case. And so it's a cost effective or a reduction of cost approaches which could be utilized by capturing these existing conditions. And the best aspect is like, in case if there are any change management aspects which happens when you design these kind of plant utilities which are there, you could reduce these number of change orders during the construction facility which is there. Now I'll take you through a next example where I'll talk about one of an add-in which comes from these organizations which build these scanners like TopCon and the Faro. But current example is more from the Faro side of it basically. And what I'll talk about is like a plant model does not mean only equipments and does not mean only piping elements, etc. there are certain add-ons which is being developed from organizations like Topcon, Faro, etc., which sits on the top of your tools like AutoCAD, Plant 3D, Revit for that matter, which is therein, or they also have third-party facilities in order to scan these information which is therein basically. So what you could do is like in the same top of Plant 3D, you could see some additional add-ins which you see on the right-hand side corners, like your as-built modeler, as-built analysis, as-built plant, etc. So that's an example of Faro which is there in basically. So what you could do is like you could bring these scanned images from ReCap to Plant 3D, and what you could do is like Plant 3D has got a project manager which is therein, or the location where your project resides. So you could name this particular project which is therein, saying that it's an as-built project. What you could do in the next set is like these images which you saw in the earlier slide, it looks like a model, but it's a scanned images, and it's of minute point cloud information which is therein basically. So this add-in, what it does is like it sets out the parameters of your point cloud, and what you could do is like you could also do measurements on the top of these scanned images which are there in basically. And what you could also set up is like the density of the point cloud information, you know, which could be set on a scale of 1 to 100 which is therein, and exactly to fit that you could define the coordinates, define the auto calibration measures which are therein, and define the parameters of the point cloud. While you're doing that, also select the area or crop the area of the information which you want to use for conversion of these information from the auto method to the command line aspect which is there basically. Now, when I talk about these scanned steel elements which are therein, what you could do is like in case of Plant 3D, what you could do is like you could locate those elements in the plant model which is therein, whether it is a steel element. And while you're doing this steel element, the whole of the model might comprise of steel elements which are of different sizes for that matter which is therein basically. When I say different sizes, it could be something related to DIN standards, it could be related to IS standards, European standards. Now what you're doing is like take up your plant model, you import those information which is therein, and select from the catalog as to what element needs to be converted into what size of the steel structure element. So this something command from Faro, which lies on the top of Plant 3D which is therein, what it does is like it selects your scanned information from the advanced catalog which is therein, and there is an active set of information that has been retrieved, and you could match those attributes basically, preferably depending upon the current catalog and the current your data set which is therein, which talks about those steel element, map those properties which allows you to convert into those steel elements. The next step while you do these is basically, for example, depending upon the type of the tool. For example, if it is something related to a plant, it might be either an MEP facility or it could be a plant project. So while you're importing this as-built plant model, it also asks you the tool which you're trying to use. And for example, Plant 3D can model structural elements, but the detailing of that steel element cannot be done in Plant 3D. So preferably you'll use tools like advanced steel to do the detailing. In case if it is something related to ducts, cable trays, etc., or MEP facilities, preferably I'll use Revit MEP for importing those information. And similarly, there are functionalities for importing Plant 3D pipes, Plant 3D steel format. So this example which I'm talking about, as it's a Faro example and a Faro scanner has been utilized, this could be imported inside advanced steel. And what we could do is like we could select that as per our current design criteria, we'll be using I section belonging to certain country codes, whether it is UK sections, use your UB sections, and also predominantly define the sizes which are there in basically. Now, once you have defined the standards which you're trying to use in, what you could do is like, for example, while you're placing these elements which are therein, we also have tools like fitting these beam commands, like specifying the endpoints, snapshots which are therein, defining where that element will lie when you're trying to model it, what would be the type of the profile of that particular steel element which is there in basically, whether it should be, you know, the center of that eye section, top of that eye section, or you know, the bottom of the sections which are there in, how will the rotation of that eye section will be basically. So you detect all those information and to push those information in this particular toolbox which is there basically. Now what happens is like, after this particular aspect, the slider will actually talk about those points which has been erased, and it will try to recalculate, and then you could insert your beam on the top of it basically. Yeah, and you could use tools for fitting those processes, etc., in the top of Plant 3D basically. Now, while you're pushing those information, what you could do is like, you could you know, push on fittings, whether it should be, for example, if it is a built up section, etc., if there are plates which are lying in order to connect two different sizes of the plates which are there in basically, or it should be automatic alignment and placement, etc. So those batch fitting processes could be defined on this particular slide which I'm talking about basically. Now, once this particular aspect has been completed, what we could do is like this Faro scanner, you know, takes you through these exact steps, and once the process has been completed, you see that there is a steel element which is overlaying on the top of your scanned element which is there basically. Yeah. So what I'll do currently is like, I have hidden those scanned aspects which are there, and what you could do is like, whatever you see in circles are nothing but to do with the rotation of that particular steel element which is there basically, and it places those steel elements on the top of it basically. That is how you start modeling on the top of the scanned steel structures. Now, each of these elements axis could be edited. Preferably, you could move on the axis of these sections, and you've got tools like align axis tools in the Faro as built in order to align or you know, align this particular steel member which is there basically. Now, for example, in the particular earlier slide, you might see that the steel members which were created, preferably it was not exactly aligned to my column sections. So those aspects could be created or edited by using the extend functionality which is there through the Faro add-in, which exactly aligns to the center of the columns which are there in basically. Yeah. And what you could do is like, while you're using these extend steel to steel command, you could talk about joining these elements on the top of Plant 3D, where these elements could be interlinked with each other in order to do your connection detailing as well, basically. The other aspect which you could do is like, while you're trying to, you know, bring these elements, you could also push information like the constrained aspects which are therein, like the shortening of the members which are therein basically, the extension of the members which are therein, what should be the rotation tolerance aspects which you're trying to follow in, etc. Those parameters are already available inside this particular add-in, which allows you to, you know, model these elements basically. Now, there could be examples of objects coming in from, you know, AutoCAD, like if there are piping systems. Currently, I'm only importing the structural elements. So there are no piping elements. So I could say that there are no pipe support elements, etc. And do these aspects piece by piece. So this particular add-in also has got something for plant structures, even for MEP elements as well in basically. So you overlay on the top of Plant 3D and say that there are no plant objects which form a part of this model. And what you could do is like, once this particular exercise has been completed, you could bring into tool like Advanced Steel for doing it further steel detailing. Now, in order to do these exports, preferably we also have facility in Plant 3D to export into a file format called as SMLX in order to bring from scanned to intelligent information and then detailing of that particular element which is there basically. So here is where I've imported those information into advanced steel via the SMLX file format which is there in basically. And the beauty is these SMLX file formats can also be done in, like if it's something related to steel structures which you want to import in Revit. Revit also has this functionality of importing the SMLX files. Plant 3D also has the capability of exporting it to Revit, advanced steel, and any other tools which are available basically. So it converts these objects into intelligent objects which are there basically. So that's the whole process of using the as-built scan tool coming in from Faro. And these as-built scan tools could be utilized for converting those details into intelligent information which is there basically. That's a small recap as to how Autodesk ReCap Pro works in. As I said, there could be different ways and processes of doing it. I could also take this information from ReCap to Plant 3D and then bring into tools like Navisworks basically. I could have an existing plant, I could have an old plant which could be lying on the top of the whole project basically. So this is how you could overlay your model with respect to the as-built model. We also talked about how to clean up your recap information, basically identifying the parameters of your recap model which is there in basically, or overlaying the recap and the Navisworks file which is there in basically. So the Navisworks information can also be overlaid on the top of your scanned model inside Autodesk ReCap which is there basically. Whatever you see on the right hand side, these are nothing but the snap points where you could, I'll just move this a bit earlier. Yeah. So the right hand side image which you see in basically, it talks about where your scanners are located and the point of visualizing that particular information basically, where the scanner has actually scanned that particular data basically. So this is how a plant or a Navisworks information or a Revit data could lie on the top of ReCap by using the ReCap functionality which is there in basically. Now, as we are proceeding towards where we saw the process of whole scan to BIM by using tools like ReCap along with Plant 3D, which is therein, we also talked about the as-built facility of scanning by third-party tools which are available on the top of Plant 3D, like the Faro scanning functionalities which are therein, which could sit on the top of Plant 3D, etc. But what's the whole reason of using it basically? Once you have created your digital information and you could create your models which are therein, it is very, very important to use technologies of BIM for plant design in order to have a better visualization of your plant project which is therein, improving the mode of communication, collaboration, and coordination between your the design team which is therein, between the owner operators or the respective stakeholders of that particular project which is there basically. Using BIM information like the one approach of scan to BIM could also help you in doing the faster project setups which are therein. The cost management aspects could be improved because you're not doing it with the old paradigm way of using 2D in that case, and it could also help you in reducing a lot of costly errors which happens in and which is quite expensive in case of a plant project which is there in this case basically. So those are the key benefits actually, where you could use the whole process of scan to BIM and you could utilize tools like ReCap, Plant 3D, Revit, Navisworks for that matter to create your plant project in this case basically. Now, whatever tools I talked about in today's presentation, which is there, they all form a part of an important solution, which is called as the Autodesk AEC collection, that is Architecture, Engineering and Construction collection. The portfolio comprises of more than 32 product portfolios, comprising of both desktop products as well as the cloud portfolios which are there. On the right hand side, you see something called as BIM 360, and recently we have released a new functionality on BIM 360 where we could do direct design collaboration with BIM 360, and we'll be talking about this much in detail on my webinar on the 9th of this particular month, basically, where I'll talk about the whole of these processes in detail, which is therein. And today I typically stressed on very important tools, that is Revit, Advanced Steel, Navisworks Manage. I talked about ReCap Pro, which is there, and also Plant 3D for that particular matter, basically. So in case if you're already utilizing AEC collection and you want to do this particular process of scan to BIM, then see that you have these tools already available inside AEC collection, basically. And there are certain reasons why we should use AEC collection. Preferably, as it comes in a single suite, which is therein, you have a greater offering, greater value of that product portfolio, which is therein. And the AEC collection could help you in different processes, whether it is a building project, infrastructure project, or a commercial plant projects, etc., which is therein. And the individual stakeholders have got more choice and flexibility as to which tool they want to use from the portfolio which is therein, and preferably, handling those projects depending upon the type of services which you're offering in. It's basically one particular collection, so you need not talk about separate tools. We're only talking about one AEC collection which could sort out all these purposes, basically. We are at the end of our presentation, and the presentation is now open for Q&A. You can post your questions in the chat window. So the chat window is now on. Please post your questions in the chat window so that I'll be able to answer your questions. So in case if you're not able to see the chat window, there's a chat window at the bottom. Please post your questions in the chat window at the bottom. So you might see certain poll questions on your screen. Please respond to the poll questions, please. In case, meanwhile, if you have got any questions, please post your questions on the chat window. Okay, so we have already got few questions which are therein basically. The first question is about the scan to mesh feature, which is therein. Manoj, that particular feature was there as a part of earlier recap. We do not have that feature currently inside Recap Pro, which is therein basically. People have asked about the presentation and the recording link. We will share those information shortly with you basically. My colleague will share the same with you. There's a question asking about, is it possible to scan select services to scan in a plant basically? Preferably if it is a bigger plant and you might have the scanner scanning everything, preferably you might have to select tools which could crop those or edit those information on the top of your scan in case if the entities are very, very closer to each other basically. You have facilities or tools to do that, or you could do even a small photographic image from your scanners which are there and which will help you to do selective scans basically in a plant project basically. That's the first thing. There's a next question which comes from Rohit. He's asking me, can we use this kind of workflow in the bridge construction? Yes, it could be used in the bridge construction aspects as well in basically. And there are different facilities and different kind of scanners available for infrastructure projects as well basically. So scan to BIM approach is not only for plants, but in short, it could be applicable for any projects which you want to digitize basically. In order to get a good registration in ReCap, how many scans should be taken basically? It all depends upon the earlier scan which I talked about a basement facility where the scanner took the scans in 8 different locations, and the range of that scanner was quite good preferably, and which took almost 80 minutes to process it. So depending upon your equipment which is therein and the quality of your scan which you want in basically, there's no such thumb rules as such basically, but more the number of scans, the model might also become heavier in certain aspects which is there basically. Is there any link between Civil 3D and Plant 3D? So for example, depending upon the type of your project which you're doing from scan to BIM, if it is a plant project, preferably I'll use the workflow from ReCap to Plant 3D. And in case if it is something to do with infrastructure projects like bridge projects, etc., I'll use either the workflow from ReCap to Revit or then to Civil 3D basically. As such, both of tools, that is Civil 3D and Plant 3D, are intelligent objects which are therein, and preferably both of them use the same file format, for that matter DWG. But again, it's basically an intelligent file format which is there basically. The next question is, can we import the point cloud information? So the whole process which I'm talking about, either import scanned images. We also have the facility of importing point cloud data in ReCap as well in basically. And there are different ways and means these particular information comes inside of ReCap basically. And all our separate BIM tools have the facility of bringing these scanned and point cloud information inside the softwares which are there basically. So somebody was asking me when there's a next webinar on the Power Platform. Please share that. We'll share the links shortly on those webinars as well, and my colleagues have already emailed those information to you. Preferably the next webinar is on the 9th, where I'll be talking about the whole of the plant project process which is therein using the AEC collection tools basically. If there are any more questions, please post it on the chat window. Yeah, so there's one more question which is therein, which talks about the add-in which I talked about basically. So answering your question, these add-ins are different. Like for example, Topcon has got tools like Collage, etc., which again works with integration with Revit and the Plant 3D, which is therein basically. Faro has got its own add-on which we talked about basically. Similarly, there are different add-ins coming from InfiBIM, etc., which sits on our Autodesk platforms to ease out the process of converting from scan to BIM, which is there. Hope that answers your question, and we are at the end of our presentation. Thank you.